morning everyone. Ito po yung report ko yung about sa coefficient. What is coefficient of variation as a measure of relative dispersion? You should note that the range semi-third quartile range or quartile deviation and standard deviations discussed earlier are expressed in the units of original scores. Thus, they are a measure of absolute dispersion. Let us say one distribution of 10 scores in mathematics may have a standard deviation of 10, and another distribution of scores in science may have a standard deviation of 5. If we want to compare the variable of the two distributions, can we say that the distribution with standard deviation of 10 has considered another example? One distribution has a standard deviation of 8 meters, while another has a standard deviation of 15 pesos. Can you say that the latter distribution is more spread than the former? Or can we compare standard deviation in meters and pesos? The answer obvious. We cannot conclude anything by lifting comparison of measures of two dispersion because they are different units or different categories. This measure of relative dispersion is also known as the coefficient of variation. This is simply the ratio of the standard deviation of a distribution and the mean of the distribution that is. So ito po yung solution para po yung coefficient of variation. The above formula indicates the coefficient of variation is the percentage value. Thus, if the mean of score of the student in mathematics is 40, the standard deviation of 10, then the coefficient of variation is computed as. So, sa pag-compute po ng coefficient of variation, yung standard deviation is 10, tapos sa student in mathematics is 40, tapos i-times ng 100 para makuha yung kung ilang percent siya. So, 10 divided by 40 is 0.25, then times sa 100 is 25%. Suppose the mean score of the students in science is 18 with standard deviation of 5. The coefficient of variation is. So, ito po yung another example ng pag-compute ng coefficient of variation. So, students in science is 18, then standard deviation is 5. 5 divided by 18 is 0.277, then round off, tapos times 120%. Looking at 10 and 5 as the standard deviation of mathematics and science scores, respectively, this may lead you to judge that the set of scores in mathematics is twice more dispersed than scores in science. From the computed coefficient of variations as measures of relative dispersion, we can clearly see that the scores in mathematics are more homogeneous than the scores in science. How is deviation applied in a normal distribution? The standard deviation is viewed as the most useful measure of variability because in many distributions of scores, not only in assessment but in research as well, it approximates the percentage of scores that lie within 1, 2, or 3 standard deviations from the mean. To better appreciate this point requires an understanding of the normal distribution. The normal distribution. The normal distribution is a special kind of symmetrical distribution that is most frequently used to compare scores. It has been found that when a frequency polygon for a large distribution of scores of a natural phenomenon and scoring characteristics including IQ, height, income, test scores, etc. are drawn as a smooth curve, one standout which is the bell-shaped curve. As seen below, this curve has a small percentage of observation on both tails and the bigger percentage on the inner part of the curve. The shape of this particular curve is known as the normal curve, hence the name normal distribution. So, ito po yung illustration ng normal curve. It is also called Gaussian distribution, named after Carl Friedrich Gauss. This distribution has been used as a standard reference for many statistical decisions in the field of research and evaluation. So, in assessment, the area in the curve refers to the number of scores that fall within a specific standard deviation from the mean score. In other words, each proportion under the curve contains a fixed percentage of cases as follows. So 68% of the scores of fall between one standard deviation is below and above the mean. 95% of the scores fall between two standard deviations below and above the mean. 99.77% of the scores fall between three standard deviations below and above the mean. The following figure further illustrates the theoretical model. So, the areas under the normal curve. From the above figures, we can state the properties of the normal distribution. First, the mean, median, and mode are all equal. Second, the curve is symmetrical. As such, the value in a specific area of the left is equal to the value of its corresponding area of the right. Thirdly, the curve changes from concave to convex and approaches the x-axis, but the tails do not touch the horizontal axis. And number 4, the total area of the curve is equal to 1. What a standard score? So, in cases like this, we cannot find the answer as merely relying on a single score. More concretely, if you get a score of 86 in English and 90 in physics, you cannot conclude that you perform better in physics than in English, simply because 90 is higher than 86. Say you later learn that the mean score of the class in English was 80 and in physics the mean of score was 95. Z-score. There are many kinds of standard score. The most useful is the Z-score, which is often expressed as raw score in relation to the mean and standard deviation. This relationship is expressed in the following formula. So, ito po yung formula ng Z-score. If raw score are expressed as Z-score, we can see their relative position in their respective distribution. So, ito yung illustration ng comparison of score distribution between different means and standard deviations. In the above figure, a score of 56 English indicates better performance than a score of 90 in physics. Let us suppose that standard deviation in English and physics are Z and 2 respectively. We can express raw score as this score. So, ito yung example. Z equals 86 score in English minus 80 over 3 is equals to 2. Ito din sa bilang. Then ito yung illustration ng different raw scores in 1 Z-score distribution. Z-score. As you see in computation of Z-score, it can give you negative number, which simply means the score is below the mean. However, communicating negative Z-score as below the mean may not be understandable to others. will not able to say to student that they got a negative G score. A G score may also be a repeating or non-repeating decimal, which may not be comfortable for others. One option is to convert A G scores into A T scores, which is A transform standard score to do this. There is scaling which A in of 0 and A G score is transformed into mean of 50 and standard deviation is this score is multiplied by 10. The corresponding equation is. So ito yung example para transform natin yung G score sa T score. For example, a G score of negative 2 is equivalent to a G score of 30, that is 5 plus 10 times negative 2. So 50 minus 20 equals 30. So this is po yung another example. Looking back at the English score of 86, which resulted of a G score of 2 as shown figure 8.7, G score equivalent is 17. D scores. Another standard score is certain from standard line. With 9 explain the scores are 9 points each. Now this score distribution kami is 0 and the standard deviation is 1. The scale domain is 5 and the standard deviation is 2. So now this standard deviation by like the T score, and we calculate the T score by multiplying the T score by 2 and adding 5. So ito may example. Example, scores in stunning scale have some limitations since they are in a 9-point scale and expressed as a full number. They are not precise. Different G score or T score may have the same stunning score equivalent. So ito po yung illustration ng G score, T score, at stunning. In the assumption that stunning scores are normally distributed, the percentage of cases in each band or range of scores in the scale is as follows. So, ito yung score. Then the percentage of score. Then, ito naman yung illustration. The equivalent of difference commonly used standard score. Yung kanina, tapos ito yung the normal distribution in the standard score. So, yun lang.